All right, hey guys, welcome to day 3 of Learning at Home. Today we're going to be reviewing section 8, and I'm going to give you today and tomorrow to work on the assignment, and then Friday I will post the answers, and then you'll check your own work, and if you have any questions, you'll ask me what you did wrong, and we can do a video chat or whatever works best for you. So then we're looking at the quiz for this section is going to be on Monday. So you will see a link for that um, in the future. So today I'm going to do a few examples from this section and make sure we're all up to pace on graphing those piecewise functions. So we'll look at example number 1. So the function is going to be two pieces, 4x plus 5 when x is less than or equal to 0, and 1/4 x plus 2 when x is greater than 0. Okay, so again, we will have the two pieces. We'll make two tables for those. So x is less than or equal to 0 and it's 4x plus 5. If x is greater than 0, it is 1/4 x plus 2. So you'll see I write it all down twice. I know it's extra work, but that's okay. And then make an xy table for the first one. Make an xy table for the second one. And then so what value do we have to pick for both of them? 0. Remember that this one is going to be closed because of the less than or equal to symbol. So closed. This one's going to be open because of the greater than symbol, no line underneath. And then the inequality also tells us the other values we can pick. X has to be less than 0, so we would pick -1 and -2, and that would be enough. For this one, x has to be greater than 0. We also have a fraction, so I'm not going to pick 1 and 2. Since my fraction is 4, I'm going to pick multiples of 4. So I'm going to pick 4 and 8. And I may or may not graph the 8 because it might be too big for me to worry about. Now I plug it in. So if I plug in 0, 4 times 0 plus 5, 4 times 0 is 0. 0 plus 5 is 5. If we plug in -1, 4 times -1 is -4. -4 plus 5 is 1. If we plug in -2, 4 times -2 is -8. -8 plus 5 is -3. Okay, there's those points. Next one, 0. 1/4 of 0 is 0. 0 plus 2 is still 2. 1/4 of 4, remember the 4's will cancel, so it's going to be 1. 1/4 of 4 is 1. 1 plus 2 is 3. 8 divided by 4 is 2. 1 times 2 is 2. So 1/4 of 8 is 2. 2 plus 2 is 4. So there are my values. And I didn't bring any graph paper home with me, so I'll do this on lined paper. I'll show you how to do it on lined paper if you don't know. Just draw yourself a couple of axes. And then I'll look at my point. My first point is 0, 5. So I'm going to do 1, 2, 3, 4, 5. And it's a nice big closed circle. My next point is -1, 1. So -1, 1. And then -2, -1, 2, 3. So right there. So I start at that nice big closed circle and go through those points with an arrowhead going in that direction. And my other one is 0, 2, nice big open circle on 0, 2. And then it's at 4, 3, so 1, 2, 3, 4. 4, 1, 2, 3, right about there. And then 5, 6, 7, 8, 3. Or I mean 8, 4, sorry. And then I start from that nice big open circle, go through those points, arrowhead in that direction. The other thing you might be asked for, or that you will be asked for, is what's the domain and range. So we'll go ahead and do that. Domain values, we can pick any x value. It's all real numbers. The range, see, it goes down forever. It also goes up forever. So the range is all real numbers also. Let's look at another example. We'll call it number 2. All right, this one is going to be h of x. All right. It is 5x minus 5 when x is less than 2, and it's going to be negative x plus 3 when x is greater than or equal to 2. All right, so then, again, just like before, I'm taking all that information and rewriting it. So when x is less than 2, it's 5x minus 5. When x is greater than or equal to 2, it's negative x plus 3. Make my xy tables for each. And then what value do I have to pick for both of them? Because my inequality just says 2, I have to pick 2. And then my inequality tells the other ones that I'm going to pick. But before I pick those, I make the note. That's a less than symbol, no line underneath. So that's going to be a big open circle that has a line underneath of the inequality symbol. So that's going to be a nice big closed circle. Okay. Now I'll go to my other values. X has to be less than 2, and there's no fraction, so I'll just pick 1 and 0. This one, x has to be bigger than 2. Again, no fraction, so I'll pick 3 and 4. And now all I have to do is plug in those values. What's 5 times 2 minus 5? 5 times 2 is 10. 10 minus 5 is 5. What's 5 times 1 minus 5? 5 times 1 is 5. 5 minus 5 is 0. 5 times 0 minus 5 is negative 5. We plug it in these values to this function. Negative 2 plus 3 is 1. Negative 3 plus 3 is 0. Negative 4 plus 3 is negative 1. So we've got all the values we need. Now we just have to plot them on the graph and state the domain and range. Okay, so I've got my axes drawn. You'll notice I'm not using a straight edge today. That's okay as well. It'll be fine. We're at home, right? Okay. First point, 2, 5. Right, 1, 2, up, 1, 2, 3, 4, 5. And that's a nice, big, open circle. Next point is 1, 0 here, and then 0, negative 5. 1, 2, 3, 4, 5. Right there. Connect those with that ray. Second one, 2, 1, 1, 2, 1. Nice big closed circle. 3, 0, 1, 2, 3, 3, 0, and then 4, negative 1. Okay, got it graphed. Now we just state the domain and range. Domain, what x values can we pick? We can pick everything less than 2. We can pick everything bigger than 2. We can also pick 2. That's everything, all real numbers. What's the range? So this one has a high point there, and it's everything below. So it's going to be less than, because it's an open circle, and it's everything below. This is 1, 2, 3, 4, 5 up. So it's everything below 5. It does not have the line underneath, because that 5 is not included because of that open circle. So there's the domain and range of that. We'll do one more piecewise example, and then I'll give you just those sketches that are nice and easy. So this will be number 3. This time our function, we'll make it g of x. It's going to be, I'm going to give you this example just so you know. Negative 2 when x is less than or equal to 0. And it's negative 4 when x is greater than or equal to 1. So this time you'll notice our numbers don't match. That's okay. Just like before, we'll write it down. When x is less than or equal to 0, we get negative 2. When x is greater than or equal to, not 0, sorry, when x is greater than or equal to 1, we get negative 4. Okay, so this xy table, what value do I have to pick? 0. For this xy table, what value do I have to pick? 1. Okay. Now I have to pick values. Oh, also before I do pick my values, I like to make that big denotation. Line underneath, this one is closed. This one also has a line underneath, so it's also going to be closed. All right, let's see. We have to pick values that are less than 0, so this would be negative 1 and negative 2. We have to pick values that are bigger than 1, so we'll pick 2, and we'll pick 3. Now, this one's weird. It just says it's always negative 2. So no matter what you plug in, you get negative 2. So these are all negative 2. No matter what values you pick, you always get negative 4. There's no variable in it, so it's just that number every time. So what does this look like when graphed? Let's look at that. Okay. My first point is at 0, negative 2. And it's a nice big closed circle. My next one is at negative 1, negative 2, and negative 2, negative 2. Whatever we pick, so it's a horizontal line that direction. The other one is at 1, negative 4. Nice big closed circle. At 2, we're at negative 4. At 3, we're at negative 4. At 4, we're at negative 4. At 5, at 7, we're at negative 4. It doesn't matter. It's always at negative 4. It's a horizontal line this direction. Okay, so easy to graph. The domain and range of this are weird. The domain is not all real numbers. You'll notice there's nothing in between 0 and 1. So x is, this is kind of its own, it's just what it is. X can be less than or equal to 0 because of those, and x can be greater than or equal to 1. But it can't be anything between 0 and 1 because that's not part of our function. So that's a weird one. The range is also weird because it's those horizontal lines. It's exactly that and it's exactly that. It's nowhere above or below those two things. So the range is y equals negative 2 and y equals negative 4. It's a weird domain and a weird range. That's why I wanted to show you that example. It doesn't go up or down. It's just exactly flat, right? So that's why the range is weird too. All right, so next ones, we're just going to do some quick sketches real quick. This will be number 4. So f of x is the square root of x minus 2 and then plus 3. Okay, so here we're just looking at shifts and we're doing generic shapes of that graph. So we have to denote two things. What does that minus 2 mean? Remember, inside of the symbol of inclusion, it's the opposite direction. So that one's actually going to go to the right 2. Outside of the symbol of inclusion is up and down, and that's what you would think. It's going to be up 3. So when we graph that, we're just going to go right 2 and up 3, and that's the only point we're going to graph. So we'll just make a nice small one for these. Right 2 and up 3. So that's the only point I'm going to plot. And then I just have to remember, what does the square root function shape look like? It looks like that. Let's do another one. 5. This f of x is going to be the absolute value of x minus 1 plus 5. So this one, again, we have two shifts that we need to look at. Inside of the symbol of inclusion, it's either left or right. Since it's minus 1, it's the opposite of what you'd think. You'd think it'd be to the left one, but it's actually to the right one. This one is plus 5, so it's going to move it up 5. So it's pretty much the same as before, except for this time it's a absolute value function, so you just have to remember that shape. So this graph we'll go right one and up 1, 2, 3, 4, 5. That's the only point we're going to plot. And what does the absolute value function look like? It's that sharp V. So it looks just like that. I have 2 more examples of sketches for you. Number 6 is going to be f of x is x plus 3 squared minus 2. Okay. Again, 2 shifts to look at. Inside of the symbol of inclusion is left and right. It's plus 3, so that's actually going to go to the left 3. Outside is up and down. Since it's minus, it's going to go down 2. So we will plot that only point, and then we just have to look at what is the shape of that graph. So left 3 down 2, left 3 down 2. It is a squared function, so that's the parabola. That's the nice U shape. Look something like that. And the last one, we'll call this one h of x this time. Why not? H of x is going to be negative absolute value of x plus 2 plus 3. Okay. All right, so this one, we've got 3 shifts to look at. This one makes it go upside down. Remember that. There's a negative out front. It's going to flip it upside down. And the other ones are the same. Inside of the symbol of inclusion makes it go left and right. So that one's going to be left 2. This one's going to be up 3. And that's the only thing we have to worry about. So we'll quickly plot that. We'll go left 2 and up 3. Now it is an absolute value function, so it's that sharp V, but it's upside down. So it's going to be upside down V. There you go. Okay, so the link on the hub for the paper assignment, you can print that off if you want, or you can just look at your computer screen and work on a separate sheet of paper. But you're going to be doing 2 through 48, the evens. And remember, you have today and tomorrow to work on that. And then we will post the answers on Friday, and then you can ask questions on anything that you missed or anything that you're still confused on. And then on Monday, you'll have your quiz. So good luck. No video tomorrow. Just work on the assignment if you don't get it done today. See you later.